Hi folks, so the topic we're going to be going over today, guys, is transformation geometry, but specifically the area of rotations within transformation geometry, okay? Often in questions, guys, especially at the higher level paper where this comes up, then this would be the part on the transformation geometry question that can throw students off a little bit. They're so used to practicing axial, central and translations in class, but when it comes to the rotations, this can be the place where they might lose some marks, okay? And it's often the actual area where it carries the most marks in the question. So, we're going to run through a couple of little bits on that there today. There's probably one or two other little bits that I won't be covering, but they come up often in exam questions. We'll practice them when they come up, okay? But first of all, I have two of the same images, and we're going to do two different types of rotations, okay? So first of all, I've got this image here, and I've got a point R. We're going to start with this one. And on this image here, what I want to do is I want to rotate it about point R anti-clockwise at an angle of 60 degrees, okay? So essentially, I want to rotate this object, not clockwise, which would go that way, anti-clockwise this way at an angle of 60 degrees, okay? So I want to rotate it anti-clockwise 60 degrees. Now, essentially what I'm going to do is I'm going to take every one of these points, okay, A, B, C, D, and E, so A, B, C, D, and E, and I'm going to connect them all up. So I'm going to zoom in there, and I'll just move it over so you can see it a little bit better. So A, B, C, D, and E, I'm going to connect all of them up, alright? And I'll start with, might as well just start with the closest one. I think that'll be the clearest one, okay? So I'm going to start with C. And I'm going to draw a line to C like that. And basically what I want to do is I want to rotate C around 60 degrees. Okay? So, first of all, I will get my compass, put it on R because that's my rotator point. Pencil point on C, or biro point in this case. I want to rotate it until it's about 60 degrees. Now, I'm assuming somewhere along there is the 60 degree mark. What I often do, guys, depending on the size of your protractor, you might have to extend out your line a little bit. So maybe a little bit down here, just so you can get an accurate mark with your protractor. So pop my protractor on there, and what I'm going to do then is just make sure it's all lined up equal. And I'm happy with that now. What I'm going to do is I'm going to mark 60 degrees. 10, 20, 30, 40, 50, and then 60 there. Okay, and at that 60 mark, connect that back to R. Okay, you don't exactly have to connect it, but I'm just showing you that that angle inside in there is an angle of 60 degrees. Okay, and what I've actually found there is the image of C as it rotated anti-clockwise 60 degrees. So that now is C1. Okay, and you would do that the exact same for all the rest of the points. Okay, so now I'm going to do it for B. Okay, so connect it up to B, extend it on both ways just so I have a good marker. Mark out my 60 degrees. 10, 20, 30, 40, 50, 60. Okay, I know that's the mark there, but what I'm going to do this time, just to keep it a bit neater and a bit tidier, I'm going to rotate B. Okay, and where my mark originally was for the 60 degrees, I'm going to line that up with R. I could just make a mark there like that. That now is my B1. And you can see where this is going, which is the same then for D. Once again, 60 degrees. Marking that there, so 60 degrees, 10, 20, 30, 40, 50, 60. There's my mark. I'm going to rotate it around. This is D this time. Okay. And mark that again, and look, I'll do the line again this time, and what you'll actually see is the angle inside in here from here to here, that is 60 degrees as well. And I have now found D1. Just to show you all that then, I know D1 connects up to B1. Yep, straight across, and they both connect up to C because that's kind of the top of it. And then at this point, okay, if I wanted, I could save myself a bit of time because I know the line BD is perpendicular to the line DE, so I could at this point then do a bit of rotating, get my angle there, but I'm just going to continue on. Okay, it would save time, but practicing the technique. So or down to these, down to A. Once again, make sure I get the right line. So there's A, put it on there. That's perfect. Once again, mark my 60. So there's my 60. Just mark that. I actually want to extend this one out as well, as it does get a little bit confusing inside there. And from R, rotate A around. As you can see there, just have to extend out my line a little bit further. And now I've found what will be known as A1. Okay, and connect that up to B. And then the very last one will be E. So depending on what steps you take, you could do the swinging the arc first, as you can see I'm doing here. And going to connect that up. Okay, could do the 60 degrees, but I could actually save myself a little bit of time here. And what I could do is I could take the distance from A to E there, like that. And I could go from A here and mark it there. Okay, that will actually give me that. And then just to make sure I'm fully accurate, I know that the line AE is parallel to the line BD. So let's see how this works out. Rotations can be a funny one, and accuracy. Okay, we'll see how this works out. And it's looking like it's coming pretty close. Yeah, happy with that. And then obviously then we know that these should be parallel as well. And I'm happy with that as well. Okay, there we go. That is the rotations of an image about a point or at an anti-clockwise at 60 degrees. Okay, so you can see there, you can get it a bit quicker. You probably don't have to do it for every point. Okay, but it is important to understand that there is certain elements then obviously here, like AE. I could have taken that distance once I had A to mark it out there. Okay, as long as I had E as an arc swung around. Okay, if I was to actually join E then back to R like that, then the angle in between this line and this line should be 60 degrees. Okay, now the last one here, guys, is another one here, question that often comes up. Okay, I'll zoom out there just a little bit so you can see it a bit better. Right folks, so the next question we actually have here is the same image, okay, and we're given C at the very start and we're given C1, the position of where C1 is going to be and where C is going to move to. Okay, but we don't know how we're going to get there because we don't have a rotation point. So often a question like this might say something like, rotate the object from C to C until it reaches C1 through an angle of 120 degrees anti-clockwise. Okay, so once again we're moving in this direction anti-clockwise. But what we're going to have to do is basically, they've given us the information there. I said it's 120 degrees. Okay, so what we're actually going to use is kind of like a principle of triangles here, because we know in triangles you have an angle of 180 degrees. Okay, and we're always going to base it off an isosceles triangle. So I'm going to connect C to C1. Okay, and if we think, I'm just going to draw in a triangle down here. Okay, and we know if the top point of a triangle, bear with me a second. You're probably going to get the idea of what I'm doing here now in a second. Okay, so you can see there I've drawn a little triangle in down here, and we know if we want to rotate something, let's imagine this point here is our C and then this is C1, and we know if we want to rotate something 120 degrees, so that angle in there is 120. Okay, what are these two angles if it's an isosceles triangle? Okay, so 180, take 120 is 60. That means the sum of these two angles is 60. It's 60 divided by 2. Therefore, these two angles are going to be 30 as well. Okay, so that's what principle we're going to apply there. Okay, and basically we're going to help that use that principle to find our rotation point. Okay, up here somewhere. Okay, so I'll just zoom out there again so you can see that a little bit better. So what I'm actually going to do is, from here, we want an angle of 120 here, okay, and we worked out then that the other angles down here, in this position and this position, are going to be 30 and 30. Probably should have drawn that a bit bigger, apologies for that. But what I'm actually going to do there is, I'm going to just use a little bit of sliding set squares. Okay, going to line up this with my line C to C1. If it was working out at a different angle, guys, you'd use a compass, okay? Or sorry, not a compass, a protractor. But in this case, because it's 30 degrees, I can use my 30 degree set squares. So you can see here, just 30 degrees this way. And then from C1, just move this over the other side. 30 degrees that way. And what I've actually found here is an angle up here 120 degrees, and now I found my R, okay, which is my rotation point. So that's it there, guys. Now we have found our rotational point, okay, and we have basically, the first job is already done for us. We've got C about to C1, so if I was just to do that, I could show you there, and I could put my compass point on R, put my pencil point, or in this case the biro point C on C, and as I rotate it around, it should match up with C1, and we can see that it does. And that angle there is 120 degrees. So now we have to apply that principle to the rest of them, going back over here, completing the same process, okay? So if I just do it for the first one there, I'll do it for B, okay? So connect that up to B. I am going to rotate around the point B, around there like that, okay? It's going to be in here probably somewhere. And what I'm actually going to do then is I'm actually going to extend on my line from B to R. Okay, and after I've extended it on, I'm going to get my protractor, and this is just repeating the steps that we did in the previous question. The only difference in this question was we had to find the rotation point at the very start. So 120 degrees, 0 around, 90, 100, 100, 120. Okay, and what I've actually found there now is, oh sorry there, just check that again. Make sure I'm 100% accurate on that. Yeah, I am. That there, guys, is 120 degrees. Okay, so technically that is my B1. Now I want to do the same with D1. Let's just get that one done as well. So D1's going to be up there somewhere. And what I'm going to do is connect up R to D. And extend it out both sides, just so I got something accurate to work with. Put my protractor on that line, and then measure 120 degrees. 120 is around here, and then connect that back to R. Okay, and what we can actually see is we've actually found D1 here. So there's D1. And now I'll do the exact same thing with very last one. I'll go down here and I'll do A. Turn it around there. So I need a distance both sides. Extend that out. $120. There it is. And extend that out as well. And then rotate it around. As you can see there, I have now found A1. And same as last time, I'm going to save myself a bit of time here. Find E. E is going to be somewhere up there. But if I take the distance from A to E, and it should be out along here somewhere, and I'd imagine that is it there. That's going to be my E1. Okay, so we're going to connect all of those up. I'm use a bit of sliding set squares just to make sure it's all accurate. So there's my B1, B up to D, and D to C, and B down to A. Chances are they're perpendicular. D to E should be parallel, depending on my accuracy, a little bit out, just a little bit, and then hopefully not too bad here. Yeah, this side's a little bit better. Okay, there we go, guys. That is how you would rotate about a point R that we haven't found, and we located the rotational point there. Hope you found that helpful, guys. they're kind of two rotations that often come up. This will probably be the trickier version in that you have to find a rotational point, but after that they essentially repeat themselves, the steps. Okay, so best of luck with those guys, hope you found them helpful.